Hi, my name is Ron Nothman. I'm a local Bribie resident. I've been in the building game for over 50 years. I hold or have held 7 different building licences and 3 heavy machinery operators licences. My talk today is science and fact about why the existing Bribie Bridge needs to be demolished after a purpose-built 4-lane bridge is built and commissioned. Not 1950s technology, 2024 technology. This talk is totally non-political. I'll explain in basic terms: engineering, architectural design, construction, and other issues associated with this. So let's get into it. In 1957, contract was awarded for $716,000. That's the equivalent of about $13.5 million in 2024 dollars. Very interestingly, they needed to figure out underneath the water where was rock, what was under there. So what they did was they got 70 kilograms of gelignite, like TNT, and did 230 explosions in the water to send shockwaves everywhere and figure it all out. And what they figured out was there was a 10-metre thick layer on average across the canal, Palmer Stone Passage, and that consisted of mud, clay and loose sand, a mixture. Construction started in July 1961 and finished just 2 years later in October 1963 when the bridge was opened. In those days, Bribie's massive population was all of 600 people, but they reportedly had many thousands of people coming on weekends and public holidays. The stats of the bridge: it's 835 metres long, it's 10.7 metres wide. That was great 60 odd years ago, but it doesn't cut it in 2024, not even close. There are 2 trafficable lanes at present. They are only 3 metres wide. Minimum trafficable lanes now are 3.5 metres wide or wider. And anybody who's driven across the bridge knows how squashy it can be, especially if there's a truck or a bus there. The other major problem is that the pedestrian path is only 900 metres wide. The handlebars on my push bike are 800 millimetres wide, which leaves that much either side of my handlebars to try and ride through. So that's a problem. Altogether, there are 206 of these piles. Before they were driven in, they were 24 metres long and they weigh 12 tonnes each. Inside of the pile is steel that runs down this way and steel rings that run around this way. Standard engineering. These piles then have sitting on top of them 38 of these horizontal beams. Come back out here and let's have a look up here. So that horizontal beam then has these huge beams up here that run from up there all the way down to here. They're called the decking beams. Now the decking beams take all the load of the bridge. Load is a simple term, and all it means is the cars, the people, the lights, everything that's up there, the handrails and the cars and trucks and whatever else is up there, all added together, and the concrete, which is the road that we drive on, is all classed together and called the load. The load then comes down through this decking beam, and here in this location, the load is transferred onto a pad, which you can't see, and then that pad sits on top of this big beam. So the load gets transferred from this beam into this beam. And then in this beam, the load is then spread down through each of the 5 piles. They had a huge barge that ran out on the Pumice-Stone Passage, floated on the water, and it had a big steel rig and a massive weight on top. And they lifted the weight up and banged piles down through the mud till they got solid sandstone, which is the key, because that way all the load comes down and travels through the piles, then goes down and gets transferred to the sandstone. Engineering, perfect. Okay, so the problem is that these piles are suffering multiple problems. Now, the steel and concrete work together to cohesively to transfer the load. People think concrete is waterproof. It is not. Concrete's like a sponge in your kitchen sink. Water can travel in and out, and that creates a problem because the water that goes in, which is obviously salt water, has salt in it. The salt goes in, it has a chemical reaction, concrete, that creates crystals. And those crystals grow over time and expand and blow the concrete up. They crack to start with, but as soon as concrete is cracked, it's lost its structural integrity. It loses its ability to transfer the load. But what becomes even worse, what amplifies this issue, is that inside of here, as I said before, we have vertical steel and rings of steel. They then start to rust. And we all know what happens when salt water comes in contact with steel. You don't need to be an engineer. We've all suffered it. Rust. And what happens inside of here over time is a piece of steel that's this round in diameter expands, and that in turn also blows the concrete apart. Those technical terms, we will dumb it down and we'll just call it concrete cancer, because that's what concrete cancer is: spoiling of the concrete and the expansion of the steel. So the government wants to encase or jacket piles that they've find faulty. And the problem with that is this. Have a look here. This is now a jacketed pile. This is what's supposed to be protecting the integrity of the pile. And look at this. It's failing. Look. Look at the width of this. Look how this is pulling apart. And once you get a crack like this, the water can free flow. It doesn't have to try and permeate through the concrete. It free flows in and out. That's amplifying the problem of this concrete cancer. Here, look again, over here, more problems. And this is what is being used to remedy the situation. Now, the government engineer, in one of the reports that the government had done, specified that 80% of the fluid that is trapped inside the existing piles will stay there when this is encased. What does that mean? It means that the chemical reaction that originally caused the problem continues and amplifies, and everything gets worse inside. So problem is that we have a situation of where the government proposes to spend $100 million more on jacketing the piles because they've wasted a decade or more on their own reports where it said, and I quote, in 2013, a government report said exactly, an underwater inspection identified the need to encase more piles. That was ignored. Something that should have been instigated and sorted out immediately was ignored. And only 8 piles have been encased up till 2020. None have been done since between 2020 and 2024. I've flown my drone across here and identified that there is only exactly 8 piles that have been encased. On the 8th of October 2020, the government stated a new bridge would only cost $200 million. Just recently in the media, we saw the government state a new bridge, that's a 2-lane bridge, not a purpose-built 4-lane bridge, 2-lane bridge, will cost $700 million. Now, that's ludicrous, and you know it'll cost more because that's the way things go. The Toowoomba bypass was a 41-kilometre long dual carriage lane expressway with a bridge on 60-metre high piles that was as long as the Bribie Bridge, 800 metres long, and that total thing, 41 kilometres of expressway and an 800 metre long bridge, cost 1.6 billion, and they want to spend 700 million just for a 2-lane bridge. Something wrong here. The biggest thing is that a 4-lane bridge, purpose built, we put a divider down the middle between the 2 lanes. So if there's ever an accident on one side, it doesn't spill over onto the other side. We can then turn the existing remaining 2 lanes into one-way traffic each way. Bribie Bridge never gets shut down again. Another positive is that we can build a purpose-built pedestrian separate to motorised or wheelchair or push bike lanes. I also suggest that every 150 metres we have a small outcrop and rust-proof benches are placed on there so that older people who want to walk along the bridge can sit and relax and go stage by stage. And for other people who just want to sit up there and look at the view, there's plenty of seats for everybody. We can also be environmentally friendly to our lovely pelicans. In the past, we all know pelicans pooped on the windshields of our cars. Let us build in the new bridge, in the design, purpose-built Pelican perch. So Pelican perch goes out over the water, and instead of being a round pipe, which is hard for the pelicans to, big fat feet to grab onto, we make a flat perch with rough sections on it so they can stand there comfortably. And they can be part of the iconic view. So people say, oh, but the iconic Bribie Bridge, and the present government's been pushing. We can't demolish this bridge. It's iconic, it's iconic. And they've been revving up the Bribie public and other members of the public. We've got to keep the old bridge, it's iconic. So let's throw hundreds of millions at the old bridge. But what they didn't tell you is the deception that's been involved with that. The new bridge, as planned by this present government, is planned to be 4 metres higher than this bridge on the northern side. So let us stand on Sylvan Beach and look back this way with the new bridge in place. What will we see? We'll see a big bridge overtowering the existing bridge and piles coming down. The iconic views of Bribie Bridge will be lost forever. Let's now look south of the Bribie Bridge. From the pier all the way along, we look at the Bribie Bridge, and what do we see? We see the Bribie Bridge on this side, and on the other side, 4 metres above it, we see another bridge and piles coming down. So the iconic view from the south looking north is permanently lost, forever. And most people don't think about this. Lost forever. My way around this, if you want an iconic Bribie Bridge, the new bridge is designed, if the public so desire it, to look like the old Bribie Bridge. It has 2024 technology, it has 4 lanes, it's got great pedestrian and separate traffic, it's higher to allow boats to easily pass through, even on high tide. It's got the Pelican perches, it's got the seats, and in conferences that I've had with my structural engineer who is a concrete specialist, he said, this bridge will never, ever be sorted out. But the new bridge, you'll have a minimum of 50 years before you have to do anything to it. And the bridge will have a minimum life expectancy of 120 years. So why are we going to pour in hundreds of millions of dollars in ongoing maintenance on a bridge that the government stated had 7 years left? That's in 2024, 7 years left in life. So one of the other positives that I'd like to say is that this bridge, all the concrete is broken down and the government can reuse it on its own job, recycle concrete, or it can on-sell it to private enterprise. Secondly, the steel that's inside all the structures, once the concrete is stripped off it, goes back to the steel mill and it's recycled. So you get a win-win. And on top of it, instead of the government paying to throw it away, they can recycle it. And even if they only make $1, they're still not paying to get rid of it. So that's a big win too. Now, the one thing I'd like to say that's really important, it doesn't really matter what government's going to get in. What's really important is, and I'll state this, that they have the brains and foresight to do this job properly. In 50 years of business, my motto was, I never want to come back to ever do a repair or fix it up. We will supply the best parts. Yes, it costs more, but we will supply the best parts, do the job properly, and it's finished forever. So, biggest thing I want to leave you with is this, relating to these piles. And as you've seen, relating to this sleeving of the piles. And I liken it this way. You have pain in your mouth and you go to the dentist. The dentist looks inside your mouth and he says, oh, you've got a half a dozen teeth that are rotten, full of decay. And you go, okay, sort it out. So the dentist goes in there and he puts amalgam in all the teeth that have a problem and he says, all done, see you later. And you go, but hang on a second. It looks really good, but you didn't drill the decay out. Oh, it doesn't matter. It'll be all right. It's fine. Well, hello. Common sense tells you that if you leave the decay in, no matter what you put on top of the decay, it's never going to be right. It's never going to be right. It's never going to be right.